click on OK. It's done. Click on here, launch. It's quite slow for right now. So this is the one which I have been using for my config file as well. Now what I can do is launch ADEL. We can do it one with the same as well. Since I have already defined a state, I will be loading that. Click on apply. Not EMS actually. I'll be using the one which I have already specified. Okay. Now I'll be checking what is my initial conditions right now. That is, initial conditions are right now q equals to 1.8 and q bar equals to 0. Let's see, both are at 1.8 and 1.8. Hopefully we will be getting a desired results. We'll be simulating. Okay, there happens to be an error. Okay, so new config file means I can't load my previous data from now on. So I will be using my previous config file that I have already created for myself. Go to view, file, open. We have Sram tv.config. Okay. Now this is one config file. I'll be launching ADEL. Session load state. Now we will be removing it, checking out what is the initial condition again. 1.8 and 0. So let's see what we are going to get. Okay, so this is what we have. So this one is actually a read one operation. As depicted earlier, we are getting a desired result. We can change the initial conditions as well to get our read 0 results as well. So we can go for simulations, convergence 8, initial conditions. I'll be saving my q to 0, apply, q bar to 1.8 or logic high, click on apply and OK. So check, give an ADL run and netlist and run. Now this is read 0 operations. So since these two operations are verified, we can say all the other operations are verified. We can also perform it write 0 operation by keeping it 0. Okay, run. So these are basically my pre-layout simulations which I have been showing you for once again without changing my config to AV extracted. Let's see what will be happening. Since I'm able to I'm still getting read 0 operations actually, which is correct to my initial conditions which I've been set. Yep, I'll be changing my initial conditions now. I forgot to do so, that is the reason I'm getting such plot. Convergence 8, initial conditions, Q should be set to 1.8 volts over here or logic high. Click on apply and the Q bar should be bring down to logic 0. Apply, OK, check. Now I guess we have been able to plot a graph. Yep. Now this is a write 0 operation which has been done for pre-layout synthesis. Now to get into post-layout synthesis, go to your config file which has been found using this. Go to tree view, I0, select set instance, go to AV extracted and then save and then recompute the hierarchy file. Since it's done, we'll close now Using the same ADEL operation, I'll be going with ahead. There might be an error. Let me go and resolve it. Launch ADEL once again. Click on apply. Send. Search for initial conditions again. Q equals to 0, Q bar equals to 1. Click on OK. Now run the simulation again. So now there is some error with the file which has been incurred right now. I'll check and show you once again in a moment. Okay, so there was a bit of an error due to network issue. I recompiled my config file, which is word file. It's going up. Q. This is write 0 operation, which is verified from over here, and I can also specify my read 0 operation from over here. Click on apply, ADEL, run. Oh, I must save and check. Close this window and run ADEL, netlist and run. It's running. It has actually, it didn't pop up. So yep, now this is going to be my read one operation. As for my initial conditions, I haven't changed them, so yep, it has to be my read one operation. I'll go and simulate for read 0 operation as well. Read operation just means that what has been stored at the Sram, it must exactly copy it out the same as well. You can actually see the deep disturbance state as well. And as per my initial conditions, I have been satisfied logic 1 over here, so now we will change it 0 Q bar, and going ahead we will go for 1.8. Click on apply, click on OK. Again running the simulations. So now as we can see, this is my logic 0 or read 0 operations with the Q bar reading 1. So all of my operations have been verified over here. Everything has been successfully done after layout. So yes, we can go ahead and perform GDS2 operation over the file. So we'll close this. It's on, I guess, yeah. We'll go ahead with this. Close ADEL. No, I don't want to save the state. Now for going to GDS2, you first need to export the GDS file over here, the stream file actually, which is extreme. The stream file, what I need to save over here is, I will be using my folder R610. This is not my folder actually which I'll be using. I'm using this for this. Sram underscore 2.jds. Click on save. Library which I'll be using is Sram.5. Sram is the cell. Selected view will be layout. Click on OK. Technology file as GPDK45 nanometer. Use automatic layer mapping. Now click on translate. So as we can see, it says completed 0 error and 0 warning. Click on yes. Now as this the big scale instances are 6, this means I am using 6 transistors which have been instantiated for my layout. as well as everything. I have 5 cells. I have been using standard vias which are 3, path segments are 74, and there is no error and no warning while I do this. Okay, so now for the next step, import stream file which you require will be stored in the place you have signifies as output. Sram45, Sram Gds-2 file, Sram Gds library, 63 Sram45 nanometer. Top cell is Sram. View will be my layout view. I will be attaching a library which is GPDK45 nanometer. Now we need to change this to the one I have just got my hands on, extreme file which I have been just put out. Okay, Sram underscore 2 to signify Sram, you're generating it for the second time. Click on translate again. This happens to okay. So there's one error which I forgot. It's to be streamed. The library which I need to have signifies is the one which I need to have my output. So yep, we'll be going ahead with the one which I created, Gds-Ii_45. Top cell will be Sram2, layout, and everything remains same. Click on translate again. The error is just because of the technology file that I'm using. The new error is just because the cell name isn't valid. So I'll change my cell name now. Port stream GPT45, everything will be remain same. Underscore OJS, we'll go translate. I think this won't actually satisfy because I need to have the same cell name as the one I'm importing. So import stream. What I do is I create a new library with my SRAM over there, keeping everything scheme. We will go for translate. Completed with 0 error and 1 warnings. Ignore the warning, there's nothing to do with them. Same things will be in instance 6. Standard is 3, path segments 74, or paths use 74, rectangle 69, cells are used 4. Next, now if you want to use Gds-2 file, go for file, open, go for the library which you have created right now, Gds-Ii_2. This is your SRAM. It will be showing your layout view. Okay, session. We're here, and I have my Gds-2 file from over here. The whole purpose of this video to get from schematic to Gds-2 flow was to understand the schematic to Gds-2 flow, which is being undergone through a course Digital IC Design taken by Professor Mohammad Wajid, which is the principal chief investigator for C2S program. C2S program is chip to starter program at EMU, which is funded by Ministry of Electronics and Information Technology, Government of India. I would like to thank and acknowledge all of them for this, and thank you for watching the video. Thank you so much. We will be exiting our Cadence tool. Exit. Over here we'll be also performing an exit operation from the terminal. Yep, we are here and we will be performing logout. Thank you so much. Thank you so much for watching the video. This is Oja Sharma signing off.